All right, let's take a look at this word problem. Mr. and Mrs. Gomez are buying carpet for their square-shaped bedroom, okay? So they have a square-shaped bedroom, okay, and which measures 5 yards along each wall. So it's 5 yards here, 5 yards here, okay? And the carpet is $23 per square yard, $23 per square yard, and $6 per square yard for installation. $6 per square yard. They get you any way they can, don't they? Square yard for installation. Okay, so now it says how much will they spend in all. So you got to pay, obviously, for the carpeting, and then you got to pay for getting it installed. Before we do this problem, let's take a look at some of the area problems. So if you look in your workbook, there's a whole slew of area problems for the rectangle, for the square, for the triangle, for the parallelogram, trapezoid, circle, okay? But what you have to know, remember, is that area is measured in square units, and that everything needs to really be in the same units to make it easier to do. So that's what we're going to do today. We're going to make sure, and they're in the same units. Okay, so now let's take care of this problem. We know the area of this is length times width, or side times side, which I think is what your formula sheet says. Doesn't matter, because this length times width would be 5 times 5. Side squared would be 5 squared. That's why they have it there like that. Okay, so we know everything's in the right units, so now we're going to find the area. And in your workbook, it says side squared, or length times width, same thing, because an area is a parallelogram. I'm sorry, a square is a parallelogram, and it is a rectangle, so it doesn't matter which formula you use, you'll get the same result. Area equals 5 squared, or 25 square yards. Recalling that area, again, is measured in square units. That's how much carpeting you need, 25 square yards of carpeting. But the cost of the carpeting is $23 per square yard. So we're going to have repeated addition here, because $25 for the first yard, $23 for the first yard, $23 for the second yard, all the way up to 25 yards. So we have the cost is 25 times 23. Okay, if we multiply that, and again we're multiplying, we'll get $575. So that's the cost of just the carpeting. But now remember, it costs you $6 per square yard to install it. Don't you wish you could install it yourself? So for installation, you have $25, right? I'm sorry, 25 square yards, but $6 per yard. Okay, so you have to pay $6 for every square yard for installation. So that's $150 for installation. So now the total cost is the cost of the carpeting, which is $575, plus the cost to install, which is $725. So that's the answer to that question. You had a lot going on. You had to make sure you accounted for the carpet itself and then for the installation fees. Okay, so that's the area of a square and some additional stuff that might go along with that. All right, let's look at some other problems for area. There are some things that we haven't really done yet. We haven't taken a closer look at that triangle where the height was outside, drawn outside the triangle. And we haven't seen this other shape that you see in your workbook, which is called a trapezoid. So let's look at the two of those. Okay, so let's take a look at this first one, this triangle. Okay, now remember that the height has to be from the top of the triangle to the bottom. That's why it's drawn outside. Remember, the height is drawn perpendicular, so there's a right angle there because you have to go straight down. And this is 8 1/4 inches. This is 12 inches. And that's the distance from here to here. And then this is 14 inches. And recall that the area of a triangle is 1/2 base times the height. Well, 1/2, the base is 12. The base is truly from here to here. The height is 8 1/4 inches. So we're going to multiply this. Now this is up to you whether or not you decide to use this as a fraction or a decimal. Doesn't really matter. First thing I might want to do, since this is even, I'm taking 1/2 of 12. 1/2 of 12 is 6. If you don't believe me, watch what we can do. We can go 1/2 times 12 over 1. We get 6. Now this is up to you. 1/4 is 25 cents. I can either use 8.25 here, or I can change this to a mixed number. You might want to put 8.25 here. Absolutely up to you. Pick your own poison, you know? So now we're multiplying really 6 times 8.25. And when we do that for the triangle, we get 49.5, and it's inches, square inches. And that's all there is to it. But your choice, whether you want to change this to a decimal or to a fraction. But you can't leave it a mixed number, remember. You can't multiply mixed numbers. You have to change them to either improper fractions or decimals. And I would only change it to a decimal because it's a terminating decimal. If that was 1/3, I would absolutely not have changed that to a decimal. Okay? Now let's look at the parallelogram. Oh, I'm going to have to draw this. All right, here we go. Take a nap here. I'll be there in a minute. Okay. This line here is the height. That's how tall it is, 6.1. And this is miles, okay? And this is 5 miles, and this is 11 miles, and that's all you have. Okay, the formula for the area of a trapezoid, you ready? I'm going to put this over here because I think I need more space than this. The trapezoid actually has 2 bases. It has the upper base and the lower base. So this is the height. The height is drawn to one of the bases. So there's one base, and here's the other base, and here's the height. All right. Formula for a trapezoid is 1/2 the height, little b plus big B. Some books put a plus b. It doesn't matter. But it means just add the 2 bases, 1/2 the height times the sum of the 2 bases. That's the area of a trapezoid. So here we go. The height is 6.1. Little b is, well, it doesn't matter which one's little b or big B. 5 plus 11, doesn't matter which order you put those in. Watch what we have here. This is kind of cool. A equals 1/2 6.1 times 16. Remember, it doesn't matter which 2 factors you multiply first. We got 3 factors. How about if I just take 1/2 of 16? 1/2 of 16 is 8. That'll make my life easier. If you want to show the work by putting 16 over 1, that's fine. But that is 8 times 6.1. That makes that 48.8 square miles. It's a big trapezoid. Square miles. And that, you know, that could be a trapezoidal piece of land, okay? That doesn't mean it's a real trapezoid, okay? So it's 48.8, you know, just a trapezoid that you see hanging around. 48.8 square miles. Okay. Let's look at this next question. All right. This asks you for the exact and approximate area of a circle. The other day we did circumference of a circle. Circumference of a circle was 2 pi r or pi d. Today we're doing area. Area, as you notice in your workbook, is pi r squared. I remember that one is the area because it's a square. Because area's got to be in square units anyway. Okay, we're going to do the exact and approximate. Okay, we're going to remind you how to do this. So first we're going to do the exact over here. Then we're going to do the approximate over here. Ready? Exact means, here's the formula, area equals pi r squared. Remember, pi is an irrational number that we kind of just round to 3.14 so we can use it. But if you want the exact answer, you got to keep pi in your answer. So that's going to be really simple to do. Okay, the radius, remember, is 1/2 of the diameter. So if we have a circle whose diameter is 7, that means this whole thing is 7. We only want one little piece of it, 1/2 of it, so to get the radius. So to get the radius, we have to take 7 divided by 2, okay? If we do this, 2 goes into 7 3 times, that's 6. Okay, there's your point. 2 goes into 10 5 times, and there's your 10. Done. So it's 3.5. So the radius is 3.5 because it's 1/2 of the diameter. Okay, so here we go. It's going to be simple. A equals pi. Pi is going to say pi because we want it exact. Okay, pi, radius is 3.5 We're going to square it. Then we're going to write the coefficient in the front. 3.5 times 3.5 is 12.25 pi square centimeters, because it's in centimeters. So area is pi r squared. Pi r squared. I thought pi's are round. Pi r squared. Forget it. Okay, so area is 12.25 pi square centimeters. That is the exact answer. Okay, now you want the approximate answer. Well, to do the approximate answer, you start the exact same way. All right, you would go A equals pi r squared, A equals, but instead of keeping pi, you have to change pi to 3.14. Okay, it's approximation because remember pi is irrational, times the radius, 3.5 squared, which would be equal to 3.14 times 12.25. And when you multiply 3.14 times 12.25, you get 38.465 square centimeters. And this is an approximate answer because remember, we approximated pi from the get-go. Okay? So that's the difference between exact and approximate. Leave pi in, exact. Take pi out, approximate. Okay? Pretty cool. All right. Let's use some common sense as we look at this next question. Every time I say that to a class, they ask me, is that your common sense or my common sense? Let's just assume we all have the same common sense. Okay. All right. This question asks you, what would have the biggest area? A circle with a diameter of 10 or a square with sides of 10? I don't really want to do this problem. I want to just talk about it, okay? All right. So if the diameter is 10, then we know the radius is 5. So to find the area, we're going to go pi r squared. Remember what pi is? Approximately 3.14, a little bigger than 3. We would have to take the radius, which is 5. And again, this is more or less going on almost in my head. This is 3.14 times 25. So that's what I would be multiplying to get the area, okay? And if you think about it, 3 times 25 is 75, so it's a little bit bigger than 75, okay? This one, to get the area, you'd have to take your side and square it. Well, if I took my side and squared it, this is 10 squared. That clearly would be a lot bigger than 75 because that's 100. So which would have the bigger area? That would definitely be the square of side 10. All right? I'm going to do this next problem, and it's one of my favorite problems of all time. So you ready? I'm going to have to draw this, so this may take an hour and a half. Okay, here we go. Looks like an L. I believe we did one like this before. It was a perimeter, but this is area. Now, we do not have the area of an L. We don't have a formula for the area of an L, so that's the problem. We don't know how to find the area of an L. It's called an irregular shape. It's a shape that we don't have a formula for. So what we're going to do is we're going to split that shape up into non-overlapping shapes we know how to find the formula for. Watch what I mean. Okay, so let me try to draw this. Here we go. So this is 4, this is 5, this is 24, and this is 18, right? Okay, so here we go. I'm going to attempt to draw this. I know, it's not the scale. Give me a break. Okay, I don't have the formula for now, but watch this. What if I just did something as simple as either this, going across here, or going down? It doesn't really matter. I'm going to go across. That's one way I can do this. So now I have this rectangle, and I have this rectangle. Okay? If I can find the area of this rectangle, and I can find the area of this rectangle, I can add the two areas together, and I'll have the total area. Another way you could do it is some people like to fill in the entire rectangle and then subtract out the piece they filled in. I kind of like the addition route, but you do whatever you want. So I'm going to find the area of the first rectangle. Okay, remember rectangles are length times width. So we know this is 4. Now we need the width of this rectangle. So we know that we need the distance from here to here. That's the width. I'm claiming we know that. Okay, let's talk about how we know this distance from here to here. We know this is 4, but I'm claiming we know this. Well, if this whole piece from here to here is 18, and this piece is 5, then this piece has to be 18 minus 5, or 13, right? Because 13 plus 5 gives you your entire 18. So I know that, which is 4 times 13, or 52 square, I think it was feet. Okay, here we have, oh, it was meters, sorry. Here, for area 2, okay, I need length times the width. Here's the width, here's the length, so it's 24 times 5. 24 times 5 is 120 meters. Now all I have to do is add that up, and I got the total area I need. So total is area 1 plus area 2, which is 52 plus 120, or 172 square meters. So all you have to do is break it up into shapes you know how to find the formula of, and that's how to take the area of an irregular shape. That's it for area. Next time we're going to do something a little different that we have not even touched upon. Okay.